Hello everyone, welcome back to another chemistry video. This one is going to be about Lewis structures, or i.e. how to draw covalently bonded elements. So what a Lewis structure is it is a depiction of the distribution of electrons in a covalent bond. So these just show how the elements would be set up in covalent bonds. So it shows how the valence electrons are distributed as either shared or unshared electron pairs. So everything is done in pairs. There shouldn't, well, there can be a single unshared atom, but we're getting ahead of ourselves. So bonds are formed between electrons in the atoms, and bonds can result from an overlap of atomic orbitals on neighboring atoms. So this is how you get hybrid orbitals, because when the elements get close together to share the electron, the orbitals overlap. So that's how you end up with those overlapping orbitals, like sp2 for something that's bent, or you have sp3, sp3d, There's some, well, that's kind of most of it. But this is how you end up with these hybrid orbitals, because they're sharing an electron from the s, and or they're sharing a pair of electrons from the s and a pair from the p or the d or whatever. So only valence electrons are involved in chemical bonds, as we know. And just a quick note, remember, except for the transition metals, the number of valence electrons is the group number. So like, alkali metals are group 1, so they have 1 valence electron. Halogens are group 7, or 17, 7, so they have 7 valence electrons. So how to build these Lewis structures? So 1, you have to decide on the central atom, and it's never going to be hydrogen, because there's not enough electrons, because hydrogen can only bond with one other thing because it only has 1 electron. So normally this is going to be your least electronegative atom, unless it's hydrogen, or whatever's listed first. So say we had NH3, our central atom would be nitrogen, because it's first and it's not hydrogen, even though it's not the least electronegative. So now our second step is to determine the number of shared electrons or pairs or bonds. So there is a little equation you can do to get this, N minus A equals S, which means number of electrons needed to be stable. So that's just going to be 8 times how many elements are present. Unless you have hydrogen or helium, that's 2. A is the number available. So that's going to be your valence electrons. So, you know, if you had oxygen, that would be 6. If you had hydrogen, that would be 1. And then S is going to be the number of shared. So say we're doing NH3, still our N would be 8 times 1 plus 2 times 3, because we have 1 nitrogen, 3 hydrogen, and nitrogen needs 8 to be stable, hydrogen only needs 2. And then we would subtract that by our valence electrons. So we have 5 from the nitrogen, plus we have 3 hydrogen, and they each have 1. So that would be 14 minus 8, which would be 6. So we have 6 shared electrons shared, or we have 3 pairs. So now that we know that, our third step is to form a single bond between central atoms and the surrounding atoms. Say we're doing nitrogen, hydrogen. We now know there are 3 pairs. So now we see that, and we have our 6 shared electrons. So our fourth step is to add the remaining electrons to form lone pairs and complete the octet. So as you can see right now, nitrogen is only has 6 electrons, because each of these is 2, 2, 4, 6. But it needs 8 to be stable. So we would add to a 1 lone pair right there to get 8 and have it be stable, because elements are only going to form bonds to become stable. So now that we've done that, we need to check for 8 or 2 for hydrogen around each atom. So we see hydrogen has, this is 2, 2, 2, 2, and nitrogen has 8. And then our sixth step is to make sure the number available is the same amount. So we had 8 available, so we need to make sure we still have only 8 electrons in here. 2, 4, 6, 8. So those are the steps to building these. One thing I should note is technically in nature, this lone pair would push these down, so the hydrogens would come down here instead of be at their 120 degree spot, because we know this lone pair would push the bond angle down since the shape is bent. Okay, one more thing is, of course, there are exceptions to the rule. Boron only needs 4 to complete its octet, So if you're working with boron, you only need to worry about 4. Boron and aluminum only need 6 as well. I think this is beryllium, not boron. I think beryllium only needs 4. Double check, but I think it's beryllium. I think boron and aluminum only need 6. Phosphorus can have 8 or 10, so phosphorus can be normal or can have extra. And then sulfur and xenon can have 8, 10, or 12. And while xenon is a noble gas, it will bond and it might have some funky numbers. Okay, one last thing is, say you're doing an ion. If you're drawing ions, remember to add or subtract to available the electrons gained, lost to form the ion. So remember, if you have a plus ion, you've lost 1 electron. If you have a negative ion, you've gained 1 electron. So just don't forget to add those to your available so you have the right amount. You should always be working with even numbers and get even amount of pairs. And then once you've done that, so say you're doing PO4 3 minus, and you've done all the steps, you've figured out it looks like this. You need to put brackets around it and put the charge outside. So that way people know you're not, because you didn't do that, you would have 3 extra electrons floating around that aren't available. But this shows you that you have those. All okay. So for any ion, you need to put the brackets in the charge. And then I forgot to mention resonance structures. So this is when there are multiple positions for double or triple bond. So what you do with these, say we have SO2. So we know we have to have 3 bonds. So, but we only have 2 atoms. So the bond could either go there or it could go on the other side. These are very ugly, but I'm not really trying much right now. Okay. So what you do is you have to draw both and then put brackets around each one and draw an arrow between them to show that they can go either way. So that is how to draw these structures. The next video will be about the shapes in Vesper theory and all that jazz. So thank you so much for watching, and let me know if you have any questions.